How about we step back and just talk about different methods that can be implemented or have been implemented, let's say, over time for fuel gauge measure state of charge and state of health and those types of things.
There's the famous one, I would say, it's the column counter, which is basically it's an integration of the current through time. So you grab this integrated current measurement, you divide it for the maximum capacity, so you have like a number, and this could be the percentage of capacity that went in or out of the battery. Okay. So like if you have this value, you also compute the initial state of charge, so you can know the total state of charge of your battery. It has some downsides. For example, as you are integrating the current, if you have an error in your measurement, you will be integrated this error forever. So that's not good. Yeah. So a lot of people what try to do is to try to correct this error when you are almost empty or almost full in the battery, like when you are in the boundaries. But in the middle, like in the wide range, you are like blinded. If you have an error, you are not going to see it until you are like in the very end or in the very beginning of the battery. So what people is doing right now is trying to use a mixed model using this column counter, but also using a voltage model based, let's say, which basically uses a cell model to estimate the voltage. So we can do corrections this like in every iteration.
So before we get into the the more complex, more advanced systems, so if a column counter is used, so it's like an odometer on your car, right? It's where a speedometer might be measuring the current, and the odometer is measuring mileage, so it's measuring the accumulation of charge or discharge. Can you talk about maybe more detail? You talked about the issues when implementing it, where you have to re-zero at the full charge or discharge. What's the problem with doing that? Why does that cause issues?
Yeah, for example, if you don't accurately know the capacity of your battery, because it changes over time and over temperature, you will have like a very, like maybe 5-10% of error in your state of charge.
Just because over the life of the battery it degrades over time, or differences between cells just manufacturing, I suppose.
Yeah, all of this in this kind of method, it like results in a poorer state of charge, right? And what does it mean? It means that, for example, if you have a 10% of error, this means that your battery is going to run out maybe before you know it. Sure. And this can be translated, for example, in range, as you said. Right. Maybe your gauge says, okay, you have 10 kilometers left of battery, right? But it switched off. Right. That's going to be awful for the customer, right? And it's not going to be good.
Right. Okay. And then how about if you're, maybe let's say you have a way of recalibrating. It sounded like there's still errors in between as the battery discharges. Can you talk more detail? Why are there errors?
Yeah, because if you are integrating this current and the measurement of the current, of course, from your battery monitor, it's going to be a certain error, which is inherent. You are going to have it. You are integrated, so you are deviating for the real state of charge line. Okay. And when the system knows, like when you don't know how deviate you are from that curve until you reach
too high
the end.
Or too low.
Yeah, you don't know until you reach the end. So at the end you can do corrections, but the battery already switched off. So there's no point on right. The customer is not going to be happy about it.
Right. Okay. All right. And then can you talk the more advanced or the other methods?
Yeah. The other methods would be a voltage method using the OCB, for example. It's a very simple model, but it has like a great downside is that
Can you just say OCV?
OCV. Yeah, it's a open voltage.
Right.
Okay, and this the open circuit voltage is OCV.
Yeah.
So in this method, for example, it's the relaxed voltage. So if you are not charging or discharging the battery, for a long time, the value of the voltage that you are going to be is the open circuit voltage, right?
Okay, open circuit voltage, yeah.
So if you, for example, charge and discharge the battery, you can extract this open circuit voltage.
Right.
So the problem with this is you only can check this open circuit voltage when the battery has been in relaxed mode,
steady state
for a long time. Okay. Otherwise, you have to be you will have an error because the ESR, which is the equivalent series resistance, and because of the dynamics of the battery, until it's not fully relaxed, you are not going to see the open circuit voltage. So this model, it's not, let's say, if you are charging or discharging your battery dynamically, it's not going to be that precise.
And is that just an older technology, or is it like a very simple technology? Is that why it would be currently used?
It's a very simple technology.
Simple. Okay, for maybe applications where the precision isn't as important.
Yeah, I would say, I think it's not being used that much because if they want a simple model, the column counter, it's better than the OCB.
Okay, so that's like the simplest implementation people currently use, probably just a column counter without too much error correction.
Yeah.
Okay.
What some of them, what they're trying to do is the column counter and the OCB method. So they do column counter for the 80% region of the state of charge, and then at the end they apply these OCB corrections.
Okay.
Or they try to apply them.
Okay. So how would they apply them if the battery is just charging and then someone plugs it into a charger right away? Is it possible, or because you're saying it has to be at steady state or rest?
Yeah, they had, for example, if they do a characterization of the cell, they can, for example, you can know the voltage if you are discharging, let's say, a 1.0 Cs, right? You can know the voltage that you are going to have if you are discharging at that point. So some of the customers, they know their current profile, so they can know the voltage drop that they're going to have, so they can apply this OCB, like having the OCB with the voltage drop, and they can correct at the ends of the battery.
Okay.